Hi guys, I hope that you're doing well. Haven't seen you in a while with spring break and me being out. Um, so we're going to just go ahead and continue our study on transformations, and we're going to start today with dilations. Okay, so today you're going to learn what is a dilation basically, or how to enlarge or shrink a figure using a scale factor, and how to find that scale factor of a pre-image to an image. Now, I think this is going to be quite an easy, quick little lesson for you guys. Okay, should be anyways, I'm hoping. Of course, I say that when I have 2 degrees in math. All right, so what is that dilation? A dilation is a transformation that either enlarges or shrinks a figure or pre-image by a scale factor. So we have our Nittany Lion, and I made him bigger, and then I made him smaller. Notice nothing else changed. His orientation didn't change. He did slide a little bit, but it's easier to just show it by making that movement. Okay. I always think of a dilation when your eyes are dilated. With the doctor, it makes your eyes, the pupil bigger so that they can see deeper into your eye. But in geometry, it can go either larger or smaller. Okay, so our properties, if A is our scale factor, if it's greater than 1, we're going to enlarge the pre-image. If it's less than 1, we're going to shrink or reduce the pre-image. And our pre-image and our image are going to be similar figures, and we saw that with our Nittany Lion. Nothing changed, just the size changed. And this is not an isometry. And remember, an isometry is a transformation that doesn't change size or shape. Okay, so in this example, our solid figure is a dilation of our dashed line. We want to tell whether it is an enlargement or a reduction and find the scale factor. So in this case, my dotted figure is smaller than my larger figure, so my larger figure is an enlargement. So it's an enlargement. And then my scale factor is I'm going to take my 14 over my 3.5. And in math, we typically don't like decimals in fractions. So we're going to go ahead and divide that out, and you're going to see that your scale factor, or your A, is 4 if you just do that division. Okay. On this example, we don't have numbers, but we can definitely count. If I go from here to here, that's 3 blocks. From here to here is 3. So I'm just doubling my size. So it's an enlargement again, and my scale factor is 2. So pretty common sensey, really no math to show. I know you guys love it when there's no math to show. We wouldn't want your hands to fall off because you're showing too much work. Now, would we? All right. So here I have the triangle ABC, and I'm going to dilate it, keeping my center at 0, 0, and a scale factor of 3, and I want to graph the image. So all I'm going to do is multiply my X and Y coordinates by 3 to get my new coordinates, my A prime. So if I multiply 0 by 3, of course, I get 0, and 3 times 3 is 9. For B prime, if I multiply the coordinates by 3, I'm going to get 12, 6. And for C prime, I'm going to get 6, negative 3. Okay, so 0, 9. 12 is A prime. B prime is 12, 6. And C prime is 6, negative 3. So my triangle, just going to kind of try to draw on my lines as straight as I can. Little curve there. Cannot draw a straight line to save my life with this pen. All right. So there is my new image. Okay. Now here I'm going to take my quadrilateral and I'm going to dilate it with a scale factor of 1/4, which since 1/4 is less than 1, it means we're going to be shrinking it or reducing its size. So again, all I'm going to do is multiply each of my coordinates by 1/4 1/4, or I could divide it by 4. Multiplying by 1/4, dividing by 4 are the same thing. So for my new coordinates here, if I divide -4 by 4, I'm going to get -1. If I divide 6 by 4, I'm going to get 6/4 or 3/2. Okay. Dividing the second point, -1, 0. The third point, -2, -1. And the fourth point, -2, +1. So when I go to graph these, -1 and 3.5 or 3/2 is right here. -1, 0. -2, -1, and -2, +1. So I've taken my little quadrilateral and I have shrunk it by a scale factor of 1/4. Our last example, if I'm looking at an object under a magnifying glass, we want to find the dimensions. So if I've got a ribbon where the image of the ribbon is 10 times the ribbon's actual size, and the ribbon in the image has a width of 110, what would its original dimensions be? And I think these directions are a little odd, but I'm taking them right from your homework so that you understand them. So if my image is 10 times my ribbon's actual size and my image has a width of 1, I'm just going to divide by 10, and my width is going to be 1/10 of a centimeter. And that's really all there is to those problems. I get a couple of those on homework. Okay. So we finished up all of the different translations that we're going to talk about. Next, we're going to compose them, meaning we're going to take more than one together. And we've kind of done that through the homework, although we haven't exactly called it a composition. But we're also tomorrow going to look at compositions that mimic other transformations. But isometry, remember, isometry doesn't change the size or the shape. It can change orientation. It can change where it is. Okay, so our isometries are our translations, our reflections, our rotations, and our non-isometries are our dilations. All right, have a great night. Hope you did good on your quiz today. Miss you guys. I will see you next Monday on the 4th. So I even miss my little birthday buddy, all of you guys. So have a great day.